Okay, so the last time we look at our functions and how when we start with relations, we know when a relation becomes a function. We move to equation, so we define when an equation is can be written as a function of x. So now we're looking at a graph, and when do we say a graph is a function? So to test this, we have what we call the vertical line test, which says that if you have a graph, say, let's give an example, let's say you have a graph that goes this way, or a graph that goes this way, or let's say you have a graph that goes this way. One more example, let's say we have like a cycle. So if you can draw a vertical line on this graph, so if the vertical line cuts the graph at more than 1 point, then that is not, the graph does not define y as a function of x. For example, the first one, so if you look at this, for example, for every vertical line you could draw on this graph, you will see that this will always cut the graph at just 1 point. So this is an example of a function. So this shows y as a function of x. If you look at this, for example, if I pick any point, let's say if I pick this point, if I draw a vertical line on this line, this vertical line intercepts this point and this point on the graph. And so it intercepts the graph at more than 1 point. So this is not a function. So this does not define y as a function of x. Again, vertical line on this, for every part you draw a vertical line on this, you see that this cuts the graph at just 1 point. So this is also a function. And finally, if you draw a vertical line on this point, you could see that these and these 2 points are on the graph, and so this is not a function. This does not define y as a function of x. So next we want to see how do we identify the domain and range from a function graph. But before we go into that, we need to have this note at the back of our mind. The first is that whenever you have an interval given in terms like in square brackets, so the square bracket actually indicates that that particular point is inclusive. For example, if I have this, so this says I'm looking at intervals from 4 to 7, both 4 and 7 inclusive. So parentheses on the other hand indicate that the endpoints are not included. So if, for example, you have this, so these are a set of numbers between 4, or the interval between 4 to 7. 4 and 7 not inclusive. So if you have parentheses somewhere, it means at that point it's inclusive. For example, if I have 4 and I have 7, then I have parentheses here, you can see that by the 4 I have a square bracket, which shows that the point 4 is inclusive. By the end of 7, I have its parentheses, which shows that the point 7 is actually not included in the function. So also, you have the notion of negative infinity and positive infinity. Since we are not sure of what these numbers are, we usually represent them using the parentheses. So you always use parentheses whenever you have negative infinity or positive infinity. So now back to what we actually discussed, which is how do we identify domain and range of functions. First, we need to know that when we talk about relation from the beginning of the class, we said that your relation is always given in terms of x, y, and we also said that that the first component is always the domain of the function, and the second component is always is always the range of the function. So invariably, if you have a graph, your domain will be the set of all the x value on the graph. And if you have and the y, the range will be the set of all the value on the y-axis. For example, let's say you have a graph that goes this way. Let's say I have a point like this, and then I'm going to assume that, okay, let's start with this. And you can see that for this graph here, this goes continuously downward, this goes continuously upward. So it means if I'm starting with my domain is going to be the set of all the possible x values that I can think of. Okay, so for example, my x goes all the way to this point. So in this way, I can say my domain is from negative infinity to infinity. Remember, we said whenever you have negative infinity or positive infinity, you always represent them with, you always enclose them in the parentheses. Also, if you want to get the range of the function is going to be all the set of possible y values. So all the y values. Now you can see that this actually goes this way and this goes down also. So it means my y, I can think of my y to be, let me choose another color. So I can choose my y to be the set of all the numbers that goes in this interval. So that means my range is also from negative infinity to positive infinity. All right, so let me give you a better example to understand what we're actually looking at here. So let's say you have a graph of this function. Let's say we have this, and then let's say our graph goes, and then we have an open circle somewhere here. Let's say you have a closed circle, and then you have it goes this way. So let's say you have an open circle. Okay, you have a closed circle here. Now, in the beginning, I need to explain that whenever you have open circle at the point of a graph, open circle is more like you say in parentheses, and it means the point not inclusive. Okay, and then the shaded circle is more like what? Like a square bracket, and say this is point included. Okay, so that means for this, I'm just going to give some random values for this graph. Because I can't have a perfect graph here, so let me say this is 2, this is 4, this is 6. I'm going to assume I have 2, 4, 6, and then I have -2, -4, -6, and let's -8. So for this graph, you can see that what? We want to find the domain and the range of this function. So let's start first with our domain. Again, our domain is always what? Is always the x-axis, okay? And the range is always what? On the y-axis. So not just the only x-axis, but what x value are included in this particular graph. Now you notice that this goes to this point. Let's just assume this is point -7, let's say. So the x value does not go beyond the -7. So it means my x value actually goes from this point. Now this arrow shows that what? It goes continuously, so it goes all the way to this point. So it means what? It means our domain actually is from what? From -8 to infinity, right? Now we know that, of course, when you add infinity, we have parentheses. But do we have a parenthesis here or a square bracket? And let's go back to what we have here. This point you have here is shaded. So it means this point is inclusive. So we're going to have what? A square bracket over this. I hope this makes sense to everyone. So the domain of this function is from -8 to infinity. Now the range. The range is only what? The y values. Okay, the range is always the y values. The range is always the y values. Okay, so now if you look at this, okay, something is missing. I guess I'm supposed to have some values for this negative y. So let's say this is negative. This is -2, and I'm going to assume this is -4, just because I want to have a graph. So I'm going to assume this is -4. So again, I want to get the range. So the range is going to be what? All the possible y values. So this is the least possible y value we can have. This This is the least possible what you can have, and this is the highest possible value you can have. So your y is actually within this range. So now I'm going to have y is from what? Y, the range is from -4 to +4. Now we need to know, do we have a parenthesis or do we have a square bracket in each of these intervals? So if you look at -4, look at the graph. The graph shows that this point is shaded. So it means you're going to have what? A square bracket on this side. And then if you go up here, we can see that this point is an open circle, right? So this point is not inclusive, which means you're going to have what? We're going to have is parentheses on this side. So this is how you find the domain and the range of a graph. Now, sometimes the question might ask you to state this interval, like we have this in terms of interval form. Sometimes you might have the question which wanted to give your function, which wanted to give your interval in terms of set builder. To do set builder, all you need to do is what? So you insert builder. So all you do is to open a curly bracket and talk about the axis where you have. For example, if I'm looking at the domain is always on what? On the x-axis. So I'm going to have x here. I will put a sign here which means such that. Then I put the intervals. So the intervals is between -8 and of course I have x in between here and I have infinity. Now you're going to look at this. This is a what? This is a square bracket, which means the point is exclusive. So we can say -8 is less than or equals to x, and then x is less than infinity. So whenever you have a curly bracket, whenever you have a square bracket, it means less than or equals to, or it could be greater than or equals to, depending on where you are actually looking at. And if you have parentheses, it is either strictly less than or strictly greater than. So what about the range? Let's find the range in set builder, using set builder. So the range is going to be what? So the range is just going to be what? Of course, we're on the y-axis, so we will say y, such that we have from -4 to what? To 4, right? Now again, we have what? We have a square bracket here, which means that point is inclusive, so I will say less or equals to, and then of course here we have what? We have parentheses there, which show that the point is not inclusive, so I'm going to put a strictly less than sign here. So it means for this function, in terms of set builder, the domain is x values such that -x is less than or equals to x, less than infinity, and then the range is just going to be -4 y such that -4 is less or equals to y, less or equals to 4. So this is how you get the domain and range of functions. I hope this makes sense to everyone. So the last part of section 2.1 is how do we identify the intercepts. So you need to note first that in this case, your x-intercept, okay, will be those sort of points where y equals to 0, and then your y-intercept will be point where your x equals to 0. Of course, because we are saying function, we could say also, so this is where our f of x equals to 0, and this is where we're looking for what? For f of 0. Okay, so if you have a question, if you want to find the y-intercept, just plug in x equals to 0. And if you want to get x-intercept, just plug in y equals to 0. Again, if you want to y-intercept, you plug s equals to 0. And if you want x-intercept, you plug y equals to 0. But suppose you have a graph. If you want to get the intercept, all you need to do is what? Is to check where this graph cut across the axis. Okay, for example, let's say you have this. So this graph cuts x-axis at this point, and this point. So those points are called what? Those are the x-intercepts. Okay, and then the graph actually caught y at this point, and that is what is the y-intercept. So this is the y-intercept. So let me give a better example to understand this. Let's say you have a graph that goes this way, and then it goes, let's say, okay, so this is a little bit different from what you have there. So let's again check for x-intercept. Our x-intercept will be what? Will be this point, this point, this point, and this point. I'm just going to assume some value. Let's say this is 2, -2, and -4. So it means our x-intercept will be what? Will be -4, -2, or 2. And if you want to write this in terms of relations as pairs of numbers, you could say our x-intercept will be -4, 0, okay, -2, 0, and then 2, 0, okay. So remember, for x-intercept, your y is always equal to 0, and your y is always the second point. So the second point in this case becomes 0. So let's say we have a 2, 4, and we have -2, -4 over here. It means, again, y-intercept in this case will be what? Y-intercept will be -2. Don't forget this is point where y equals -2. So it means if I want to write this in terms of pairs of other pairs, or in terms of relation, I will say my y-intercept is what? Is 0, -2. That's when x equals to 0. Again, your y-intercept means what? Means x equals to 0. So this is all we're supposed to do for section 2. If you have any question, again, send me an email. I'll always be ready to attend to your questions.